The next section of our module on optics has to deal with lenses. And for those of us who don't have the best eyesight, this is something that we can be very thankful for. And that's that pieces of glass or pieces of plastic will actually refract that light and change the position of where we see an image, because that's how our eyeglasses work. And so I know I, for one, am very thankful that we understand this particular branch of science in a way that we can craft eyeglasses so that I'm actually able to see across the room and I'm able to tell what I'm looking at. So when you have a lens, what happens is that because now this is obviously a very, very fat lens, and your eyeglass lenses are very thin, but I've blown it up so that you can kind of see what we're talking about here. When a light ray goes into a different medium, as we've already talked about, it's going to bend. And when it exits that medium, it's going to bend again. So when you have a light ray that comes into one side of the lens, when it goes in, it's entering a more dense medium, so it's going to bend towards the perpendicular. Then it's going to travel through that lens. When it comes out into the air on the other side, it is going to bend away from the perpendicular. And so this particular type of lens, it appears to be convex on both sides of it. That is called a converging lens. And what a converging lens does is it causes parallel light beams that come in to all be centered on the focal point on the other side of the lens. And once again, I'm linking you to another video where the same lady that did the one on the mirrors is actually now going to take these horizontal light beams and she's going to put a lens in front of it, and she will show you how this lens is going to focus these parallel light beams all at one point. So make sure you check that out, because it provides a great visual to help you understand this, that I'm not able or equipped to be able to do. So again, it's called a converging lens because it makes these parallel light rays converge to a single point. Now, we're going to be drawing ray diagrams for the lenses just like we did for the mirrors, but thankfully, we don't have to worry about bending these light rays twice, because there's a simplification that we can use when we're actually drawing the ray diagrams. When we draw ray diagrams for lenses, what we're going to look at is that there is, if they're the same on both sides, then there is a line that goes down through the center of that lens, and that's where we're going to kind of focus our attention on, because obviously it bends towards the perpendicular here, bends away from the perpendicular here, and so if we focus on the line in the middle, we're going to be able to kind of get I'm going to figure out where that light ray goes just by focusing on one particular point. So when you draw the diagrams for a lens, you don't have to worry about your compass or anything like that. All you need to do is draw a vertical line, because this vertical line is going to represent the center of the lens. So we're going to work example 12.5, and this is a converging lens. Which is going to be very important to remember. You need to make sure that since you don't have that visual of which direction it's curving like we did with the mirror, you're going to have to make sure that you stick it up here what type of lens that we're working with, because the converging and diverging lenses, we'll do diverging lenses in a day or two, diverging lenses are treated differently. So these are converging lenses. An object is 10 centimeters from a converging lens that has 7 centimeter focal points. What is the appearance of the object if someone views it through the lens? Okay, so because I have a lens, that means, and the light is passing all the way through it, that means I have a focal point on both sides. So I have a focal point on this side, and I have a focal point on this side. And for this particular example, these are 7 centimeter focal points. So the 7 centimeters is right there. And it said the object is 10 centimeters from the lens. So this object is located at 10 centimeters. Now the rules for doing this are almost identical to the rules that we've done before. The only difference is that they're going to, in place of being reflected off, they're going to be passing through the lens. So I think you will see that this, again, isn't all that difficult. if I have a parallel line or a horizontal line coming in from the top of the object to the mirror, when that object passes through the lens, when it comes out on the other side, it is going to be directed through the focal point, just like that, okay? Similarly to our mirror, if we have an object or have a line that passes through the focal point, like that, it is going to come off horizontally, this way. Like that. And then finally, if I have an object that passes in place of through the radius, this time it's going to just pass right through the center of the lens. So when it goes through the center of the lens, like this, it's going to continue through the lens without being diverted at all. Now, obviously I didn't quite get these down far enough so that they were going to cross, because they're going to cross all the way down here. So I need to extend these lines a little bit. Like that. And as you can see, this lens ended up really enlarging this guy quite a bit. So if I extend this one out here, I'm not using my ruler. So here's my image, and it is going to be flipped the other direction. So what kind of image do I have here? Well, my light rays are actually intersecting. I didn't have to extrapolate anything because they're passing through the lens and they are meeting down here. So this is going to be a real image. The image is upside down from where it was before. So this is inverted. And the other thing that you can tell is that this image is much larger than my original, so the image is magnified. Okay? Now, it is possible for there to be virtual images formed. So if you draw your ray diagram, and it's going to depend on where your object is located. So depending on where you scoop this object in relation to the focal point, you may notice that this image is going to change. And so if you get to a place and you're like, okay, when I did this, my lines didn't cross any place. If you see that they don't cross on the other side, then you're going to have to extrapolate them backwards and figure out where that image is formed. So it's really not that much different than what we did with the mirrors. The only difference is in this line here that was drawn, whereas in place of crossing from the radius of curvature, instead it's passing right smack through the center of the mirror, or I'm sorry, through the center of the lens, and then it's going to go through undiverted. Okay, so you're going to get some practice doing that. And again, make sure you check out that other video where the lady's going to show you the light beams coming into a converging lens and how it makes them react on the other side.